Hello everyone, in this video lecture we are going to solve a numerical. Two identical circular loops P and Q, each of radius R and carrying current I and 2I respectively are lying in parallel planes such that they have a common axis. The direction of current in both the loops is clockwise as shown from O, which is equidistant from the both loops. Find the magnitude of the net magnetic field at point O. In this problem, we have given two identical circular loops P and Q, and the radius of both the loop is R, and O be the point which is equidistant from the loop P and Q. Now, in this problem, we are going to calculate the magnitude of net magnetic field at point O due to these both loops. So let's go ahead with the solution. We know that according to Weier's-Savart law, magnetic field on the axis of a circular loop is given by V vector equal to mu naught over 4 pi 2 pi I r square over r square plus x square raised to power 3 by 2 I cap, and the mod of magnetic field, that is B vector, equal to mu naught over 4 pi 2 pi I r square over r square plus x square raised to power 3 by 2. 2 to the 4, pi cancel with the pi, we have left with mu naught r square I over 2 times r square plus x square raised to power 3 by 2. Suppose this is equation number 1. Now we are going to calculate the magnetic field at O due to this circular coil P. So let us suppose it is BP. So mod of BP vector, this is equal to mu naught, here radius of the coil is smaller, so small r square I, current is flowing through this P coil is I, over 2 r is r square plus, and the distance of O from this coil P is also smaller, so r square raised to power 3 by 2, and this is equal to mu naught r square I over 2 r square plus r square, that is 2 r square raised to power 3 by 2. When we solve this 2 r square raised to power 3 by, and this can be written as square root of 2 का क्यूब r square raised to power 3 by 2, here root 2 multiply root 2, so this becomes 2 root 2, and here square cancel the square, so we have left with r cube. So this is equal to mu naught r square I over 2 root 2 r cube. Square cancel with this cube, we have left with mu naught I over 2 to the 4 root 2 r. This is equation number 2. Now we are going to calculate the magnetic field at O due to this circular coil Q. So let us suppose that is BQ, and this is equal to mu naught radius of coil Q also r, so r square, and current is 2I. The current flowing through the coil Q is 2I over 2 r square plus r square raised to power 3 by 2, and this is equal to mu naught r square 2I over, when we solve r square plus r square raised to power 3 by 2, we get 4 root 2 r cube. Here this cancel with this, only here we are left r. Mod of vq vector equal to 2 mu naught I over 4 root 2 r. This is question number 3. Now we are going to calculate the net magnetic field at point O due to the two coaxial loops P and Q, and let it is given by V vector. This is equal to BQ vector का mod minus BP vector का mod, and it is equal to BQ is 2 mu naught I over 4 root 2 r minus, and BP is mu naught I over 4 root 2 r, mu naught I over 4 root 2 r, and this is equal to mu naught I over 4 root 2 r. So net magnetic field at point O due to the two circular loop PQ are mu naught I over 4 root 2 r.